Good morning everyone. So today we will discuss corollary 1. In the last video we have discussed theorem 5. So today corollary 1, and in this corollary 1 theorem 5 will be used, okay, slightly. In the last part we will use theorem 5 also. So corollary 1, what it is said, if GCD of AB is equal to D, then we have to show that GCD of A by D and B by D will be equal to what? 1. So say given, what is given? GCD of AB is equal to what? D. And we have to prove that GCD of A by D comma B by D will be equal to 1. Right? So say proof. Okay, what is given now? GCD of A and B is equal to D. That means G is the common factor, highest common factor. So which implies that D must divide A and D must divide B. Okay, so you see one thing now. Say suppose GCD of say 15 and 10 is equal to 5. We know that 5 is the HCF, right? GCD. It means what? It means obviously 5 divides 15. And 5 must divide 10 because it is the highest common factor. So what does 5 divides 15 means? 5 divides 15 means that 15 is the numerator and 5 is the denominator. That is 5 divides 15 and we will get an integer number, and that number is what? 3. Similarly, what does it mean? It means that 5 will divide 10 and we will get an integer number, that is what? 2. That means this 15 by 5 and 10 by 5 is nothing but what? An integer. Similarly, D divides A, D divides A and D divides B. It means that is, this is numerator, this is denominator, right? Like 5 divides 15. So A by D and B by D, A by D and B by D are integers. Okay, it means what? A by D and B by D are integers. Understood? Because if 5 divides 15, so obviously 15 by 5 has to be a what? Has to be an integer. Okay, so again so let us start GCD of AB. Again we'll say that we know that GCD of AB is equal to GCD of AB is equal to AX plus BY, where X and Y are some integer. That is our theorem number 4. Done. Implies, now GCD of AB is given as D, so it means D is equal to AX plus BY, which implies AX plus BY will be equal to D. Now you see, we need to prove GCD of A by D and B by D. We need the numbers A by D and B by D, right? So for that what I will do, I will divide both left side and the right hand side by what? By D. Dividing both sides by D. So now if I rearrange this one, you see, it will look something like this. A by D X plus B by D Y is equal to 1. And if you observe closely, it looks like what? It looks like AX plus BY equal to 1. This whole thing is A. You assume it to be A X plus this whole thing is B. This whole bracket part is B. BY is equal to 1. So see, it looks like this. AX plus BY is equal to 1. You have to assume as this. And if AX plus BY is equal to 1, so now we will use theorem 5 that we have already discussed in the last video. So what does theorem 5 says? It says if A and B are relatively prime, then GCD of if A and B are relatively prime, then AX plus BY is equal to 1. And if AX plus BY is equal to 1, it was an if and only if proof. So if AX plus BY is equal to 1, then also what? A and B are relatively prime. So it looks like what? Ax plus by is equal to 1. Only condition is, there is one condition. that a and b must also be integer. And you see a by d and b by d are also integers, we have proved. That's why this part is important. Okay, because we have to say that why this and this are integers. We know that a and b are integers, but why a by d and b by d are not rational numbers but else they are integers, we have to show here that a by d and b by d are not fractions, they are not rational number. A by d and b by d are integers. We have already shown this because d is the GCD of a. So obviously d divides a means a by d has to be an integer. So since this and this is integer and it looks like ax plus by is equal to 1, so we can use, therefore we can use theorem 5 that a by d and b by d are relatively prime. So if they are relatively prime, so obviously their factor will be what? 1 will be the factor. So GCD of these two integers, that is a by d and b by d, has to be 1 and only 1. Understood? So this is corollary 1. So theorem 4 is also used here. Theorem 5 is also used here. So it is an easy one only. Only you need to practice a bit. Okay. So now let us see corollary 2. So let us discuss now corollary 2. If you have any doubt regarding this corollary, you can ask. Okay. So what is corollary 2? Let us see. So corollary 2, what it is said, if a divides c and b divides c and GCD of AB is equal to 1, so all are given, then you have to prove that AB divides C. So it is given as A divides C, comma, B divides C, and another given is what? GCD of AB is 1. It means A and B are relatively prime to each other. So we have to prove that AB divides C. So how I will start now? I will start with this given, that is A divides C and B divides C. If A divides C, I can write that C will be equal to, say, A. Any integer I can write, say AR I can use. Okay, AR. And it implies C will be is equal to, say, B, S. Again, S is an integer. Okay, I'll write here what? R, comma, S is nothing but what? Integer. Yeah. This is nothing but dividend is equal to divisor into quotient, and there will not be any remainder plus 0. Okay, because it is dividing, right? So it will be an integer. So dividend is equal to divisor into quotient. That is, A divides C means what? A divides C means C by A. So when I will divide C and A, so obviously the remainder will be what? 0. Because if the remainder is not 0, then how A divides C? So that's why we write what? C is equal to AR. Similarly, C is equal to BS, that is dividend is equal to divisor into quotient, right? So these two will use. Okay, how? Here, that is now GCD of A comma B is equal to AX plus what? BY. X and Y belongs to what? Integer. Again theorem 4. Okay, implies GCD of AB is given as 1, so we will use GCD of AB to be 1, implies 1 is equal to AX plus BY. Done. Which implies, now you see, I will write AX plus BY, or let it be this way only, AX plus, let it be 1 is equal to AX plus BY. So now you see, you have to remember one thing, okay, we have to show AB divides C. So you need this C, there is no C here, see there is no C. So you have to bring C, you multiply both left side and right side by what? C. Multiplying both sides by what? C. So what we get? C1 just C. Here you will get CAX plus CBY. Done. Which implies C. Now you have to put the value of C here also and here. But which value to put where? See, you need AB. I have already brought C. Now I need AB. How to bring AB? Here is already A. So if here is A, then you will not put this value, because then either it will be A into A square. So you have to put this value here. Only then A into B will come. Okay, AB will come, and here it is B. So here I will put this value AR. Then only again A into B will be what? AB. So in place of this C, I will use what? BS. In place of this C, I will put BS, because then A into B will be a B. And similarly, in place of this C, I have to put AR. See, this you have to practice and you have to keep in mind where to put what thing, okay? And only then you will get AB. So now I have AB and now I have C also. So implies C is equal to, see, I will rearrange this one, okay? How I will write? A into B, AB, S into X is what? Sx, plus A into B is AB, R into Y is RY. One more line, which implies C is equal to AB is common and it is Sx plus RY. So see, I need to prove AB divides C. AB divides C. When this AB will divide C, again, dividend is equal to, this is the dividend, this is the divisor, right? So dividend is equal to this divisor into some quotient, and this quotient has to be what? An integer. So you see, dividend is equal to divisor into, this is the quotient, and this is integer, because S, R, X, Y, S, R, X, Y, all are what? Integer. I will write that Sx plus Ry belongs to what? Z, because S is an integer, X is an integer, so multiplication is integer. It is closure property, right? Multiplication is closed under, integers are closed under multiplication. Similarly, integers are again closed under addition, so it will be an integer. So I can say, therefore, it looks like a dividend is equal to divisor into quotient, and there is no remainder, plus 0. So it means what? AB divides C. So this is our what? This is our corollary number 2. Very, very simple proof. Only have to keep in mind, you need C, so you have to multiply C to bring C. Then which value of C to put where? You need AB. So where there is A, you need to put the value of C, this one, the one which has B. And where there is B, you have to put this value where it has A. And then you take common, you arrange it in dividend is equal to divisor into quotient. It means divisor will divide the dividend. That is AB divides C, and this is your corollary 2. Okay. So in the next video, we will discuss theorem 6. Okay. Thank you.